half of this week was about finishing the discussion about nonlinear effects in fiber, and uh, the other half was about commonly used optical components and some of the performance metrics that we keep using again and again. The weekly quiz doesn't have too many difficult questions about this nonlinear effects part. They're all asking about this SBS and SRS thresholds. Just use the formula, and because the sources are not given in the quiz, just use a source with zero line width. So last week we started discussing about this nonlinear effects, which basically manifests itself in the D term in Maxwell's equations. And this polarization term is affected by higher powers of the electric field. And last week we discussed about this effects of uh, self-phase modulation. And this week we started with cross-phase modulation. And in this week's weekly quiz, I think this L effective, this formula was being used again and again. So we started with cross-phase modulation, and that huge expansion that comes up. We started with that. Then we talked about the four-way mixing, the other terms that cross-phase modulation did not cover. Then we went on to discuss about scattering and these nonlinear scattering processes. So Rayleigh scattering, we know, just uh, the primary reason of the loss in a fiber, that 0.2 dB per kilometer, that comes from due to Rayleigh scattering. And then we talked about this Brillouin scattering and Raman scattering, and uh, the use of Raman amplifiers, how when they're used, like why they're only used in uh, underwater, like submarine networks. Those were discussed, and we capped off this discussion about nonlinear effects with this nonlinear Shannon limit. How uh, we cannot uh, decrease the bit error rates just by increasing power, because after increasing power beyond some threshold, nonlinear effects give us trouble. And then we uh, started discussing about these components, but on a surface level, because uh, like these directional couplers and these multiplexers, uh, these Bragg ratings and all this. If you want to go into the full math of it, we'll have to go into too much depth and it will take too long. And because it's a technology course, so we don't care that much about knowing how it works, like why it works, but we should know how to use it. That's all. So if you want to go into more depth, you can use either the prescribed textbooks, or I think a good textbook is Yardiv. I think it has a good discussion about modes also, and this discussion about these directional couplers and all this. They will use this perturbation theory, so it will go into Maxwell's equation in depth. So if you want to know, but for this course we don't require it. And for all these uh, components, we use this performance metrics. So insertion loss is basically what is the cost of inserting a component into a link. Like without inserting a component, what would be the power? And just because of insertion, you will lose some power. In directional coupler, this insertion loss doesn't capture like uh, the loss due to the device. For example, if you input some 0 dBm power, uh, it, like 1 cross 2 coupler or a splitter will give minus 3 dB, minus 3 dB at the output ports, even though there is no loss for a perfect. directional coupler. So just by the definition of the insertion loss, that comes up. So we define this other term, excess loss, which is not used for other devices usually. Just the splitters and couplers, they use this term quite a bit. And crosstalk, that is, you want the signal to go somewhere, and other channels are also seeing contribution due to those. So these are the basic, most commonly used terms that we'll see again and again. So we discussed about fuse coupler, how to make, and then 2 cross 2 and n cross n, and how this kappa value depends on wavelength, how to make WDM multiplexer, all this. Then the second class of components, variable optical attenuator, and then polarizer, how to make those, and then polarization controller. And then we went on to introduce the first non uh, the word is slipping my mind. So non-reciprocal device, this Faraday rotator that was introduced. We just wanted to know the use of it. So this operates in the on the basis of magneto-optic effect, and common use of this Faraday rotator is in an isolator. How to make a polarization insensitive isolator, that becomes a little complicated. It was shown in class. And then we introduced the concept of circulator. And circulators are widely used. Isolators are widely used after any laser source. Then we went on to discuss about wavelength filters. Fiber Black grating is the most famous out of them, but it's not very tunable. So tunable filters also have their use, and this optical add drop multiplexer, how to make using fiber Black grating plus circulators, that was shown in class. I think to see the sizes of these components, you can check the videos. In the videos, ma'am shows these components, but if you want a close-up picture, you can check the data sheets. We'll see one or two of them. And then wavelength selective switch, we briefly touch upon. These are some of the formulae that are used in this week's quiz, as well as all of the lectures. So Raman scattering will use the similar equations, and I have not gone through the all of the math in the classes, because the first few lectures are very math heavy. I don't want to type all of them up, but I think you will be using this quite a bit. And this L effective is coming from last week, so just check those
Janak,
values.
it is 21, it is right? 21 E effective.
For Rayleigh, it will be 16. For Brilliant scattering, it is 21, I think.
Okay.
Just check the lecture.
Okay.
I think it is.
Yeah, it's
And
perfectly fine. For Raman, it's
yeah.
16. For Berlon,
Yeah.
it's 21.
Yeah. I think someone had doubt about this. The initial few questions, how they were, I think, confused about this term, because the laser source or anything is not specified. Just use a zero line with something. So just use this part. That is all.
This is my doubt that in question 1 also, they are asking that what is the threshold for in terms of SRS and SPS. So what will be the A effective in that particular question? Or
Right.
are
L
see in assignment?
L effective should be 1 minus exponential.
No, that
A effective is something for it was specified in class, I think. What is generally used for 1550 nanometer. Let me check again. Like for
A
1550, there
A
was
effective you have to given that 50 micrometer.
Yeah, 50 micrometer square or something.
Yeah, it is already given in the question. Manish.
Let me check it.
Yeah, your first question misses that, I think.
No, it
It's
is not given.
it's it's given before 4, I think. That's the same value.
See, they had given GR, L, and alpha at 15 nanometer. That's all.
Yeah, A effective was missing. That's my bad. But use the value from the paragraph right before question number 4. That has A effective, right?
A effective,
That
yeah,
is the
50.
value. Otherwise, you will have to go through the
Yes,
videos.
it is 50 micrometer. Micrometer square.
Okay, so we have to take it from the question after the line that is given question 4, question
Yeah,
3.
yeah. Basically, it needed a correction, but like, the value is from the next paragraph.
Okay.
Sorry. Okay. So these are just a few of the selected this uh, formulae and all this that were introduced. So be careful about what is in linear scale, what is in dB scale. Be comfortable converting between all those. And I wanted to show a couple of data sheets. So this one website, it gives the price as well. You can have an idea. Whenever you go for like more specialized components, you will have higher prices, obviously, and like some particular highly reputed websites will charge you more. Like German websites will charge you more. All of those, and you can see what kind of operating wavelengths you can expect. And insertion losses are usually below 0.5 dB, and it's safe to assume everything will be below 1 dB insertion loss. You can expect. So for the sizes, to get a size idea about what are the sizes of these components, uh, I think ma'am has shown these components in the videos, but if you want close-ups, you can go through this. Like, this is not inside a tube. Usually, all of the other components will be inside a standard kind of tube, and the frequency response is like this, and this uh, specific wavelength gets all reflected. This is showing transmission. So that a selective frequency doesn't get transmitted. That's all. And again, you can see insertion losses of 0.1 to 0.2 dB you can expect. And similarly, this is a circulator. Because it is wideband, prices have also shot up. It's not too bad, but still. And everything is inside these housings. Like, uh, this is how they typically sell. A component, and then pigtails are attached to them. These are like SC-APC connectors usually. So in research, or if you see some component that is being sold will have SC connectors, which are also called as like subscriber connectors. This is FC connector. Connectors are more common in labs, research, or if you see if you open up some device, some appliance, if you open it up, then you will usually see these FC connectors inside. SC connectors are easy to connect and disconnect, but like this is the most common because they make like better connections more reliably. And again, we wanted to show this insertion loss. This all of these component, all of these values. You can check in your own time also if you want. Like this OE market. if you want to know the prices of something, then like you can just visit OE Market or Thor Labs. There are other more reputed websites, but they don't give the prices right out. Like you will have to ask for quotes, then only you will get the prices. Well, that's all I had for today.
Any doubt? Class. Munish, Jagannath, have you any doubt in that assignment or any topic? Then I will be go for move forward. Have you any doubt who has joined first time or that?
In the assignment, question number
Hello.
10 was not covered. I think we told some people on Sunday also. Question number 10 was not covered in the syllabus, but it's there in the textbooks as well as you can find just by using a Wikipedia. But uh, everyone will get that mark. Just fill anything and everyone will get that one mark. And question number 11 was the other weird question. Uh,
Yes, Jagannath, you can ask your questions. Doubt.
Question number 11 to 13, sir.
11 to
13 also.
that 4 into 4 couplers which shown in figure 8 made up the 2 into 2 series suppose this one.
Yes, sir.
In this, the way to go about it is that just find a path. Like, if you want to send the signal from 1 to 1, you will the switch will look like. Wait, I'll share the whole next time. So the switches can behave like either by exchanging what is coming through the input ports, like input 1 goes to output 2, that can be one arrangement, or this arrangement. So how that translates in this picture, badly made picture, is like if you want to send to signal coming from 1 to output port 1, you will select this path. But as you send signal through this path, because of this crosstalk, you will have some. If you send say 0 dBm power along this path, you will have minus 50 dBm coming to this the other port, which is unwanted, which is crosstalk. Similarly, again, some negligible loss was happening here. Some near 0 dBm went here, and again here an unwanted minus 50 dBm will come to the other part. So like minus 50 dBm contributed from here, minus 50 dBm contributed from here. Both of them adding up will be like minus 47 dBm. Then that is how you proceed. Like find a path and it will leak power into the other parts as well and ignore the
That will
powers.
have a transmission from
Your voice was breaking. Could you repeat? Uh, you can write also. I'll check. That is how you do these 11 and 12. And here you just use the powers, no? Like, instead of 2 cross 2, you consider as 1 cross 2 or something. Like, ignore the other 4. And where 60% power should have gone, instead of 60%, which is just this 2.7 dB, you convert to linear scale. And question number 13 just asks what are the power levels. You are given that if you input 200 milliwatt power, that P1 will be minus 2.7 dB from that. Just find the ratio, what is expected. And instead of 60%, it will get some lower percent. That's it. Instead of 40% also, it will get some lower percent. That's how you find P1 and P2. And to find the excess loss of the coupler, you add P1 and P2 and see how much was input, say 200 milliwatt was given, but lower power was received. So just calculate the total power and like find the excess loss. I don't think this is a problem.
Jagannath, are you understand?
Yeah.
Any other questions?
Can you please explain by writing on the board means?
My writing device is broken.
These more 13 and 14 questions.
Sir, the
Manish,
transcription of
yeah?
Yes, yes.
Oh, I will write that, Manish.
Yeah, please.
Yeah, sure.
I'll stop this.
My screen is visible?
Yes.
Give me 1 minute, please.
Yes.
So, you have given a 2 by 2 coupler. This is your coupler. Okay.
Yes.
And your one power is splitting like the 60:40.
Correct.
So I think that I suppose with the 60 is this and 40 is this. Okay.
Yes.
And there is a insertion loss are 2.70 dB. For in this case there is a insertion loss is 2.77 dB, and for in this case the insertion loss is around 4.7 dB. Okay. Understand?
Correct.
If you given that, if the input power P out is you given that 200 microwatt, find the output level P1 and P2. They have given mentioned P1 P2 let output level. Okay, so you know that the insertion loss equation is given by tan log Pi by P naught. This is the equation, standard equation. Pi should be maybe 1, 2, 3, 4, maybe like that. Okay, it is depend upon the size of the coupler. It is 2 into 2 to 4 into 2, 2 into 6, that is depend upon. 4 by 4, 4, 8 by 8, it's Pi. Okay, and where Pi is the input power, so you have to given the two input power P1 and P2, and their ratio of the splitting given to 60/40, and through that one input there is a loss of 2.7 dB, and another line fiber loss is 4.7 dB. So simply you put that tan log P1, you have to input power you given to
Right.
200 microwatt, and that P naught, and total insertion loss that you given to that 2.7 dB. Oh sorry, for first case. So 2.7 dB equal to 10 log 200 microwatt upon P naught. From that you can calculate for that line P1, and again you have to put 4.7 dB, and then you calculate for the P2. Okay, Manish?
Correct.
So from that both you can get for P1 and P2 how much the power input power will be for in that case if the our insertion loss of the that coupler is like that. So
Okay.
how much the input power you have to applied to get the output power of 200 microwatt? Understand?
Correct.
Oh, sorry. In second case, you have to given the to find the excess loss of the coupler. So excess loss formula is tan log total P in upon
P1
P1 plus P2.
P2.
So total Pn you have to give it 200 microwatt, and P1 and P2 have to calculate from that above equations from above. If you add that and then take the log, then value you give the total excess loss in that case. Okay,
Correct. Correct.
and for that to 4 into 4 coupler, Jonik, I think that
Leave it like a puzzle.
yeah.
Leave it like a puzzle game.
Yeah, this is the puzzle. You have to take that line and then you have to calculate like that. Uh, I draw one for your explanation. Like that here if you this port you calculate and you have to that P out P1 port, then you have to calculate this is the input and there is a reflection in that case. So insertion loss is you have to given the 50 dB in every case. So in this case it is minus 50 dB. Again from this you have to add, and this one have to here you will come to minus 150 dB. Again you calculate the 4, there you add something that after 150 degree that you have to 3 more, so it is minus 300 dB, and again that 2 it is minus 400 dB, and for that it is for P1 it is around come to loss is around come to minus 300 dB if you take the select the port 1. If you select the take the port 2 it is minus 400. If you select the port 3 it is 550. If you select the port 4 it is around 600 dB. So you have to select one by one port and you have to calculate the overall crosstalk in the 4x4 switch. Okay. So you have to calculate in every portion it will be add the insertion loss. If you want that overall crosstalk suspension to be 40 degree, what would be the crosstalk suspension on each switch be? Now you calculate that overall switch B, you have to given that your loss would be the 40 dB in that overall circuit diagram. So how much that in each stage your selection should be that. So you have to just calculate that for each stage, means your first stage should be insertion loss around 5 dB, your second should be 8 dB, like example in the third stage it should be 16 dB. So total overall loss should be you have to given to 40 dB. So you have to calculate in every stage the insertion loss in that case. So it will like the puzzle. So you have to hit and trial that how much the loss should be hit. You have to play with that puzzle. Jonek, I am correct.
Yeah, yeah. Just
So you
uh,
are just to play with the path which you want to play that you have to give to force coupler and output is also 4. In between you have to give the two coupler, two into two switch. Apart
just
from
just
anything this, Namrata?
select paths, and the unwanted path will have minus 50 dB from that.
Yes.
That's all.
Manish, Jagannath, Namrata.
Sir, okay, clear, sir, clear, sir.
Okay. Any doubt, Namrata? Last class you also not attended and we have rescheduled the class for you, but you are that time you also not attended. Some people that
Sir, I didn't unable to get to know at that time.
I have even emailed you this time also that everyone I should personally email that. But now is also
So,
strength is around 10 or 11 people just joining for 231 student.
By the way, should we keep it on Tuesday or should we actually move to Sunday? Like, is
Yes,
it more
yes.
convenient?
sir, even I forgot about today's class. Like whenever I just received an email, that's why I joined. I forgot, really forgot about this.
No, if you want that, we can the shift to Sunday. We have no issue. But your convenience that like that this strength will become on again Sunday. Then this will not helpful us for us also for both of us.
Yes, sir, I agree, sir.
So if your convenience will be Sunday, then we have to put the on the Sunday. We have no problem.
So I have no issue on Sundays.
No, but there that time the Sunday only 5 people will be joined at Jagannath and at
Sir,
Manish. And
actually, sir, I don't, sir, I told you, na, I didn't get,
I
unable to
need
get the time
I
to check
need
my
also
email.
I need also from others also Namita that from like 10 student is also there 9 and 10.
Yes, sir.
So if everyone is agree on the Sunday then we can put a request on Sunday.
Sunday evening, sir. Sunday evening, sir.
Sunday evening.
Yeah, sir. Many will join. I will also join.
Okay. Any
Maybe
anyone
after, yeah,
yes, yes.
after 5 anytime, sir. After 5 anytime.
Anyone want
Evening.
to give their input?
No, I'm also okay for Sunday.
It is 3 student have replied from the 10 student. Jagannath, you are okay with Sunday? I think Jagannath left the meeting. Lakshmi, Gauri, so what is the cross phase modulation and effect of it on that optical fiber that communications? Anyone can answer that?
So, cross phase modulation is the process in which the phase, when one signal is propagating with particular wavelength, it affects the phase of another signal which is propagating with different wavelength. It affects the phase of the signals, and it can be compensated with the help of dispersion compensating fibers.
So it is the non-linear effect or linear effect?
So it is a non-linear effect because it is dependent on the input power. The refractive index will change depends on the input powers, and it is a non-linear effect.
Okay. Manish, you want to add something? Anyone want to add something?
I think
So
phase matching condition is not to be satisfied for the cross phase modulation.
yes, yes. So it is optical phase of light beam causes by the interaction with another beam in a non-linear medium. So
Absolutely.
it is a curved medium. So it is maybe we have can describe by the change in the refracting index of that fiber or that phase. So it is given by that change in refractive index equal to 2n2 I1. So where n2 is the non-linear index and intensity I1 of the beam 1 causes a refractive index change for the beam 2. So it is the intensity of the beam 1 that will change that refracting index of the phase second signal that. So effect of the phase cross modulation, it leads to an increase of the laser pulse in the medium, which allow example measurement of the optical intensity of one pulse by monitoring a phase change of the another pulse without absorbing any photon of the first beam. This is based of the quantum non-demolition non-demolition measurement. So what is happen in this case? It will interaction of the two signal in the coherent medium. So we cannot measure the intensity of the one pulse through monitoring the another pulse in that case. So we cannot distinguish what are the intensity that first pulse and what are the intensity of the second pulse at the output side. Second, the effect can also be used for, yes, for synchronized two mode lock laser using the same laser gain medium in which the pulse overlap and experience cross. Hello? Any doubt? Crossphase modulation in fiber can lead to problem with the channel crosstalk, so it may be leads to the crosstalk in that signal. Crossfade modulation also sometimes mentioned as a mechanism for channel translation, but in this context, typically refer to kind of the crossfade modulation which curl effect, but rather the change of the refracting by the carrier density in the optical fiber. So we can majorly based on the refracting index, but some people are reported that it will be on the curve effect of the medium. There is a non-linear medium in which some that equation on based on that Maxwell equations that. So explain the four-way mixing in the optical fiber. It is also
So
non-linear
in the
effect.
in the four-way mixing, what happened as we are propagating two wavelengths, like we are propagating 1551 and 1552 nanometer through a fiber. Due to four-way mixing effect, at the output of the fiber, we will get other wavelength frequencies also, which we are not propagating, and it is the number of mixing products is given by m is equal to n cube minus n square divided by 2. N is basically the number of channels
Okay.
in optical fiber communication.
Anyone want to add something? Manish? So four-way mixing is also non-linear
I
effect
think
arising from the third order. Yes, Manish.
I think phase mismatch in case of four-way mixing is producing basically 2 pi frequency wave modulation, which is having a very good intensity.
Okay.
So I think phase mismatching doesn't occur. It generates new frequency components at the output,
Yes, yes. Like that, we have the two frequency.
which we are not propagating, but it is generated at the output due to the four-way mixing
Like
effect.
that, this is the we have two frequency here, omega 1 and omega 2. What happens when they are interacting that both frequency in that non-linear medium? There is a generation of the third frequency. Maybe the intensity will be less in that case, that omega 3 and omega 4 in that case. Okay, so
Right.
what happened that by interaction the two wavelength in that medium non-linear medium, it will generate one wavelength. So it's the generation of the new wavelength, and we cannot detect in that case in the output side of that what is the that wavelength, because it will be product of the two wavelength. So it is also arising from the third order optical linearity. It occurs if there is two different optical frequency component propagate together in a non medium such as an optical fiber. So like that, there is optical carrier omega j, omega k, and omega the new frequency component causes by this. So we have this new omega that frequency that. So it is the formula that if we have the omega j k l that omega j, we can calculate that new frequency component for this formula. So it will just that causes of that new frequency. So we have the two frequency that omega 1 and omega j and omega k, we have propagated through that fiber, and by cross by non by that multiplication or by crosstalk between these two frequency, it will generate a new frequency wi and wl. Maybe which one will be generated, it's depend upon that intensity of frequency or phase of the frequency. Okay, so through this formula we can calculate that this component will be generated in this case in optical fiber. So these both the nonlinear phase modulation will be not useful for in the optical communication system. We have to optimize or minimize these phase modulations, shell phase modulations or cross phase modulations or Rayleigh scattering or Bernoulli scattering or this four-way frequency. It will be just destroy our signal in that optical communications. So we need to optimize that parameter when we have to design that optical fiber. Anyone can explain that stimulated balloon is cutting and Raman is cutting? What is the effect of that in optical fiber? What is the significance? What is the application of that in optical fiber?
Sir, stimulated Brownian scattering and Raman scattering comes under the category of nonlinear scattering, in which not only the mode will change within the propagation through the fiber, but also the frequency will also affected. These all Brownian SPS and SRS, these are wavelength dependent. This is highly dependent on wavelength, and it is given in the terms of power. The formula is given in terms of power. Uh, versus
Okay,
power in terms of wavelength.
okay. So Berlin gain spectra is sensitive to strain but insensitive to temperature. It is true or false?
Sorry, sir, can you please pardon?
That Berlin scattering spectra is sensitive to strain or temperature. It will depend upon temperature or that strain in the fiber. Why this spectra is happen, due to strain or temperature?
Sir, it is due to strain.
Okay, so it will not depend upon the temperature of that fiber or outer temperature environment on that.
No, sir.
So
Okay,
Bernoulli, I think gain spectra is sensitive to strain but insensitive to temperature.
okay. So what happen when the strain will be in the optical fiber? It will generate another phonon or like that photon, and which direction will be it move?
Sir, it is stimulated Brownian in forward and Raman in forward and backward both.
So stimulated Briley scattering will be move in the forward direction.
No, sir, backward, and Raman in forward and backward both directions.
So, where can we use any commercial application you can find in both the skirting? Any example of the commercial application we can use that skirting? Any application you can know that?
No idea, sir.
Huh?
No idea, sir.
What is the? It is advantage for the communication or disadvantage? Can we use it in the optical fiber, or should we minimize that skirting? It will useful for in communication or not?
Sir, it is useful in communication.
How how can you utilize that? That's why I asked the application. How can we use that?
I
So
don't know.
Raman threshold should be larger than Boolean threshold or not?
Yes, sir. Yes, sir. Raman threshold is three times larger than the Brownian scattering.
What is the reason?
Don't know, sir, the reason.
Huh?
I don't know the reason.
No,
I
it
know
is
the powers. It is larger than the Brownian scattering, three times larger than the Brownian scattering.
no. Raman threshold should be less than the Boolean threshold. It will always be less than that,
Okay.
because it will be move only on the backward direction. That phonon will be generated due to the strain only on that in that case.
Okay.
So that stimulated Boolean is getting originated by the interaction between the signal photon and the traveling sound wave. So it will be sound wave that atmosphere outside the optimum range. That because inside there we have not the sound wave, but in the open atmosphere some sound wave will be there in that. So it like just like when you blow air into an open ended tube, it will be generated that signal photon. So a sound wave may be generated because of the stimulated balloon is getting the single light wave is modulated by the traveling sound wave. So what happened that in the atmosphere, that whatever the wavelength, that it will be maybe the modulated in that case like that, our signal will be like the intensity of like that only. But when it will be in the come in the sound wave atmosphere, it will be amplified in that case. So stock photon are generated in this process. So because due to multiplication of the photon, or new photon will be generated and added, and its intensity will be enhanced due to the stack photon on that, and the frequency of the stack photon is downshifted from that of the original photon. So it will be moved to downshifted in that case, its frequency, not in upper shift that. So the amount of the frequency shift can be approximated by that delta is equal to 2 f naught v upon c upon it. 2 f naught is the original frequency of the signal, v is the speed of the sound wave, and c and n by the speed of that that's the original signal. Okay, so through which we can calculate that change in the frequency in the downshift due to the that SBS effect. So SBS is highly directional and narrow band. So it is not wide band. It should be the narrow band. It's because due to the amplifier, the band will be that reduced in that case. So the generated stock photon only propagate in the opposite direction of the single photon, and therefore the scattered energy always counter propagating with respect to the signal. So what is happens? Some photon will be moved into upward direction, some photon will be in downward direction, and both will be interacted, and it will be maybe downgrade that signal that in that case, or maybe some signal loss will be in that case happen. In commercial optical fiber system, an effective way to the suppress the effect of the SBS is to frequency modulate the optical carrier and increase the spectral line width of the optical source to level much larger than 20 megahertz. So we can in the, it will not useful in the optical fiber communication. We have to minimize that effect only. We can either do frequency modulate. So what happen that if you modulate that frequency, it will not so much downward, or that frequency downward will be so less. So we can suppress in that case also, or either we can increase that spectral width of the signal in that case. So what happen that if there is visibly any some SBS effect, it will not such narrow band in that case. So we can minimize that effect also that in this. So what happens in that SRS is an elastic process where a photon of the incident optical signal pump. So it will due to the vibration of that molecules and loss of the parts of the energy. So SRS is like that. In laser we have the use that stimulated emission. Laser is based on the principle of the pumping of that electron and holes pairs, and through that energy will be generated in like that. In that case, SRS is also that case is that what happens that incident optical power, that vibration of that photon or material, and what happens that signal will be vibrated on that material surface, and it will be due to the vibration it will lose its energy. So because of the energy loss, the photon re-emits in the lower frequency. So like that there is a photon in that high energy, and due to the inelastic collision of that photon, it will be shifted on the lower energy in that case. So this is the laser principle, same as the laser principle, and it will stimulate from the higher energy to lower energy. So the introduced vibration energy of the molecule is referred to as the optical phonon. Instead of relying on the acoustic vibration in the case of the SBS, SRS in the fiber is just vibration of the silica material. So in case of that SBS, we have to multiply of the photon, and but in this case of due to the vibration of the material on the silica, that optical fiber may be made of the silica or germanium, whatever material. Due to that they lost the energy, and they have to come in the lower band. So through the SRS process, pump photon are progressively absorbed by the fiber, where new photon called stock photon are catered to the downset frequency. So SBS will move into the backward direction only, but in this case SRS move in the both the forward and backward direction, both in that case. Therefore SRS can be used to amplify both co and co-antenna propagation of the frequency within the SRS bandwidth. So we can amplify that signal, that bandwidth of that signal through the SRS modulation, that SRS scattering. So SRS have the wider spectral bandwidth than compared to the SBS. So SRS also may create interstellar crosstalk in the wavelength division multiplication due to downward shift of the frequency that. So it may be result in the crosstalk of the signal in that case. In the fiber carrying multiple wavelength channel, SRS effect may create energy transfer from short wavelength to that. If you have the multiple wavelength or multimode fiber, so whatever happen that if there is the SRS scattering in that case, so a short wavelength higher frequency channel to long with the transfer of the frequency will be take place. So any doubt in that? Anything that in both questions you want to discuss? So what do you mean by the passive optical component? What do you mean by the passive? Manish?
No amplification.
Yeah? Can you again, can you pattern again?
Not amplifying the signal.
So what the type of the passive component
Not
in
amplifying the signal.
okay. So
Passive.
can you give the example of the passive optical component? Manish, Namrata?
Couplers,
Yeah, couplers is the passive. Any other you know that in a practically, or that Jonic will also explain.
attenuator,
Attenuator is the component.
So connector is a passive component, maybe
Y-
optical connectors.
yes. Other example?
Sir,
Hmm.
2 dB
the
coupler. 2 dB coupler. 50
A
50 coupler.
coupler is the passive component. Isolator, circulator, wavelength division multiplexer, filter, fiber break grating, wavelength selective switch. All are the passive component because they are used to connect the between that slices.
Splicing, sir. Yes, sir.
They are all the passive component. They are not generated their power itself. We have to given to the external power supply to make that supply that to operating that. So what is the,
Circulators.
yes,
Circulators.
yes. So what is the directional coupler? Have you know about the directional coupler? Where can you use in optical communication? Yeah, in optical fiber.
If you launch a input signal to one
One two.
port, next port will be the output.
If my the device is like that, how can you schematic or that representation of that coupler? Simple coupler.
Port 1, port 2.
This is correct. I am wrong or correct?
Correct.
So if you want to couple that two light or to divide the two light, we use the that directional coupler. It will be directed in the one direction maybe or two direction. So it will be depend. We can switch the rotator light through the Faraday rotator. Jonek will be also effect that Faraday rotator. We have used the 45-degree that rotation that to operate this. So it will be depend upon that working principle. Is depend upon the Faraday effect only that. So through the Faraday couple of Faraday that is the one type of component we place between the two switch. and we can rotate that light in the direction to a 45 degree that. So passive optical controller are that system for connection, manipulation and process of the optical signal. We can use that. So passive component are basic building block of the optical system, which is generally included direction, optic coupler, optical filter, wavelength division multiplexer, demultiplexer and optical isolator and circulators. You can go through that. I have explained many things in this, because that if you want to recall that all the concept, then you can go through that video also that uploaded on YouTube. That's why I use that more theory on that, because these are theory portions. So these are the component. This diagram that Jonek already explained, that this is the isolator. What is this? And what is this? From this diagram, can you explain? Can you recognize that which component is this optical? This both, that A and B.
So B is I don't it is clear, it is not clearly shown. Maybe it is a splicing machine. B. C is a I felt that B is a
So
splicing machine.
this is the wavelength division multiplexer, WDM 60 channel WDM. So what is happened that there is a one input and this will be divided into the 16 component, 16 output. This is the optical filter and this is the optical isolator. So this is the manually tunable optical filter, not a break grating. This is a tunable. We can tune that frequency or that component at. So you now this is the component commercially available in the market also, that people are using that nowadays. That so you have to even you have to not that basic principle you can see from that image, and you can identify that which optical component used in the line, or that where you are using in the company. Either you are working in that institute, so you have also to explain their student as these are the real image of that component we use in the optical communications. So for optical coupler, it can have a multiple input and output port. In general, that split or combined optical signal will the desired ratio. So 2 into 2 coupler that Manish have asked the question, and Jagannath that before that we have 2 into 2 coupler, 4 into 4 coupler. We use to redesign that 4 into 4 coupler. We use the 2 into 2 coupler, and then we have to divide that split the ratio into 60 into 40 ratio or 20 into 20 ratio, whatever you want. You can take that through that coupler, divide that. So ideally, a wideband optical coupler is independent of the both wavelength and modulation format of the signal. So it cannot depend upon the wavelength. Whatever the wavelength you can send, it can depend. It just depend upon the power of that signal. That so you can divide that power from the two, or you can combine that two signal power into one power. So the power splitting ratio of the optical coupler is defined as that PC upon PT plus PC. So in ideal optical power without insertion loss, we have to we have not inserted the output power can be given that alpha equal to PC beta PC. Uh, so this is the coupler. Where is the PC? That PS is the signal. A P reference like reflected power here. This is the PT transmitted. This is the PC coupled power. So this is the there we have to combine or split that power signal through that only. This is the that coupler, there will be, that can be split or combine that signal there. So what is the ratio? We can divide that PT by PC, that PC upon PT by PC in that. And this is that excess loss we can define by PC PT beta PS. PS is the that input signal. In practical optical fiber, due to the back scattering, this is the back scattering caused by the imperfection in the fuse region. This is the fuse region. We have this is the fuse region Z. There might be optical reflection back to the input port. Directionally, it is defined that this is the reflection in the input port. So this is the reflection can be defined dr that p this p read upon ps, or r reflection should be p reflection but a ps. So we can there is a one reflection we have given that output that in the back scattering can be that combined with the input side to the input signal, or it may be that revert back to that another signal that in the backward direction. So these are the formula through which we will calculate that how much that signal will be repeated back to that output side, or in combined with that input signal that. So through this formula we can calculate that. power. So what is the optical isolator and circulator? Jagannath.
Yes, sir. Sir, the network is very slow here. I
My voice is
can
not audible. Hello.
it's not audible for me because its network is very slow here.
So
I'm
what is the isolator and
disconnected
Audible.
circulator?
several times.
What is isolator and circulator? My skin is visible.
Yes, sir.
So can you answer something
Yes.
basic about that isolator and circulator? Anyone?
Isolator basically allows the transmission of light in only one direction. It prevents the unwanted feedback.
That is optical isolator.
Yes, sir.
And what is circulator? So what is the tap coupler? Anyone heard the name of the tap coupler?
So I think tap coupler will prevent the entrance of light in other directions. It only allow the transmission in one particular direction.
So tap
Like sir,
coupler.
optical in optical circulator is like we're entering the power light is entering in port one. It will go into the next in the consecutive next second port and then to third port.
Okay. So what is the tap coupler are 99 ratio 1 coupler where 1% power is tapped out. Means it will transmit it 99% power to output percent and 1% it will be tapped at the input side. So it is based on the 99 ratio 1 percent base. Okay. So if you want to use to transmit it 99% without insertion loss and cross talk, we can use the tap coupler between optical fiber and we can transmit 99% power. If we want to couple that 40% 60% power or 20% 10%, then we use to 2 into 2 into 4 whatever coupler you can design that through that. Okay. So if you transmit only 99% 1% ratio, then you use the tap coupler in that case. So optical isolator is a device that is designed to allow the optical signal travel in the forward direction. So it will block that reflection power. So we cannot get the reflected power in that input side. It can transfer the signal in only the forward direction. So there will be no reflection power, and so we can less reflection power. So original signal will be transmitted at the output side. If there is some reflection in that input side signal, then property of or that signals amplitude will be changed. In that case, even amplitude phase and it will be result in the crosstalk in that signal. That so we can avoid that crosstalk of the between two signal. We can use the isolator of that signal. That so this is the principle of that isolator. So you can see that there is a Faraday rotation. So what will happen that case, that there is a one that input side of that signal. So this is the input signal. 1 minute. This is the input signal you have to transmit it, and input signal has the power Pen, and this is the P reflected power. So this is one the polarizer which will polarize that signal in that either vertical or horizontal or elliptical, whatever the way that it will be polarized, and then it will be go to that Faraday coupler and it will rotate to the 45 degree, and then it will be passed through that Faraday rotator, and this second polarizer will again that polarize the light and output side. If there will be any reflected, what happen, this Faraday rotator will be block that reflection power. So it will rotate again the 45 degree in that signal, and it will again transmit that signal to that. So it will not allow back to that signal to input side. So the hello, any doubt? So a traditional optical isolator is based on a Faraday rotated sandwich between the two polarizer. So in this polar configuration, the optical signal coming from the left side that pass through the first polarizer whose optical axis in the vertical direction. So it will polarize in the vertical direction of the signal, which match the polarization orientation of the input of signal that. So it will match that whatever the input signal that orientation, it will match with the vertical side of the signal that. Then a Faraday rotate the polarizer of the optical signal by 45 degree in the clockwise direction. The optical axis of the second polarizer is oriented 45 degree with respect to the first polarizer, which allow the optical signal to pass through with the little attenuation. If there is a reflection from the optical circuit to the right side, the reflected optical signal has to pass through the Faraday rotator from the left to right. So since the Faraday rotator is a non-reciprocal device, it will then polarized state of the reflected signal will be rotated for additional 45 degree, means 40 degree before, and 40, it will be rotated 90 degree in the same direction as the input signal, thus becoming horizontal, which will be perpendicular to the first axis polarizer. So it will be rotated through the 45 to the 90 degree Celsius. So it will be perpendicular like that. It will be horizontal and the first signal will be vertical. So it will be perpendicular to that direction. So it will be not reflected back to that signal. In this way, the first polarizer effectively broke the reflected optical signal and achieved the unidirectional transmission of the optical isolator. So optical circulator is a device that is also based on a non-reciprocal polarization. It will also based on the Faraday rotation of the optical signal. Different from the isolator, it will circulate in the 3D. This is the real image. Jonek will also show you that image in that data sheet. So what it will happen that this will be that signal output. So this is signal input, this will be reflected back, and the reflection output will come on the three side. So there will one Faraday rotate, it will again that rotate that signal that. So this is the diagram that forward direction, that same as that isolator, and this is the backward direction. There will be two Faraday rotator here, one is there and second is there. So in between that we have the two Faraday rotation. So again first it will be 45 degree will be polarized, again it will be 45 then 45 plus 45 it will 90 degree, and it will become the horizontal in that case. So these are that you can go through this theory that working principle of that. So name the key working element of the WSS. Wavelength selective switch. What is the key element? Anyone can? Like that, what happened? There is a like that we have the electrical switch like that. There is a in the wavelength that. These are input of the wavelength. We can select one wavelength through that wavelength selective switch. Like lambda 1, lambda 2, lambda 3. So we use the wavelength selective switch that we want to select only lambda 1 or lambda 2 or lambda 3. So what is the key element of that wavelength? Anyone can answer. So this is a special light modulator made with a liquid crystal. So that crystal will be select only that particular wavelength. So what are the type of wavelength filter available in the market? In optical, anyone tell me the one or two name of that optical filter? Even Jonek have also explained before that start the class that summary that. I am audible or not? Hello?
Yes, sir, audible.
I am audible?
Oh, audible, sir, audible. Yes, sir, audible,
So
sir.
have you any idea about that filter? Have you heard the name of the fiber break grating in your BTech or MTech or wherever you have to heard any about?
Yes, sir, fiber break grating.
So what is this fiber break grating?
So, I don't know much, but it is used for dispersion compensating. It is basically a component employed as a dispersion compensation in an optical fiber communication link.
What is the basic principle of filter? Like that we have the filter in that analog and
So, a
digital
filter,
communication, that RC
like,
pass filter, low pass, high pass. What they are
so
doing there?
filter, so filter will pass specified band of frequency and will stop the unwanted or undesired frequencies.
Okay, it's correct. So suppose we have the in optical signal, we have the whole spectrum of the light will be coming through the fiber. Like that from like that visible or UV and that IR region will become like that from 200 nanometer to 11 or to 20 nanometer light will become through the signal that laser have the contain all the component of the wavelength of that spectrum, and you want to select the particular wavelength, then what is your what you used in that case? Suppose you want to that output side that you want to select only 400 nanometer, then how can you select that 400 nanometer? What component you used in that case?
Filter.
So filter. So which type of filter that you used in that case? Because we cannot use that analog filter in the optical communications. They are not compatible and that not suitable with that optical fiber. We
So
use the only the
filters we
optical
are
filter.
so we are using low pass Bessel filter, low pass Chebyshev filter in optical fiber communication, and
Low
we are
pass filter we
using
cannot use that. They are not based on the optical. That they are not optical component. They are that resistant and capacitance is there, or some op-amp is there.
Band filter.
Yeah.
Band pass filter.
We can use the
Band pass filter.
tunable band pass filter. We can the tune of that frequency, or we can use the most probably
Yes, sir.
nowadays use the fiber break grating. So there are that the grating is like that. There are some signal component of the fiber is there, and that will particularly select one frequency and reject that other frequency, that wavelength in that component. If you read that, you can go through that Wikipedia and that online video, or madam is also explain that fiber break grating. So nowadays we use maximum we use the fiber break grating in that optical communication. So it can particularly select one layer that lambda 1 and other wavelength can reject in that case. So one is a tunable band pass filter and other is the fiber break grating. So this is the most component we use in that. So can you difference between the fiber polarizer and polarizer controller? Have you heard about name of that fiber polarizer and polarizer controller? In your BTech, MTech, or any that advanced course or certificate, you have to join any conference, or who are working on that optical fiber that in PhD or that research that. So polarizer convert any input polarization into the given output polarization. So we have to given one output polarization, sir. Like that we have to achieve that vertical or horizontal, circular or elliptical polarization. We have to want that output side. Then we use that any input polarization we use. So this polarizer convert any input that, like that we input side we have the circular polarization, and we want that output like that elliptical polarization. We can use that polarizer in that case. Anyone want to add something? Somel? So polarization controller can convert any random input polarization to any output polarization. So it will be given that we have to not to fix that polarization. Whatever the any random input polarization, we get the random output side that polarization. So these are both are the difference. These are both are the different component. So by your application type, you can use that in that during that communication of that optical fiber. So one questions for you, that a 2 into 2 biconjugate tapered fiber has the input optical power level of P input equal to 200 microwatt. The output power at the three port are P1 is 90 microwatt, 85 and 6 point. Find the coupling ratio, insertion loss and crosstalk. Are you able to solve that questions through that formula, that coupling ratio, insertion loss and crosstalk formula?
Yes.
Yes. You have to given that coupler.
No, sir.
You have to given that P1 P out, you have to given P1 P2. So coupling ratio you have to given through the formula P2 upon P1 plus P2 into 9%. So P2 you have to given and they just divide by that just divide by P1 previous insertion loss, you get a P by into Pj. So first time that Pz equal to P naught, just P1 upon P2 naught, P2 upon P naught, P3 upon P naught. You can calculate that insertion loss in that case. And at crosstalk you have to given that P3 you have to given that 6.3 nano, P naught you have to given that. Through that you can calculate the crosstalk. Any doubt? Have you any doubt in that formula?
No, sir. No, sir.
So one question is given: optical power launch into 10 kilometer single mode fiber through 8 into 2 into coupler. So that the length of the fiber is a 10 kilometer, and there is a 2 into 2 coupler. Is P input equal to 1 milliwatt as shown in the following figure? The fiber coupler has a 10 dB power coupling ratio, and attenuation is equal to 0.1. That is the ratio equal to 10 upon 90. Coupler has no excess loss. The refractive index of the fiber core is N1 equal to 1.5. The fiber pictal at core C here that R1 equal to 0, and far end of the 10 kilo fiber is open in the air. After 10 kilometer there is a open in the air. The isolator assure only unidirectional transmission, and there is losses are negligible. So there is one isolator in between, so it will just assure that unidirection. Neglecting all the fiber losses, we have zero fiber losses. That crosstalk is zero, excess loss equal to zero, insertion loss equal to zero. Uh, what is the output optical power? Anyone can answer that? Any idea? Your reflectivity R1 is the reflectivity. It is given R1 equal to 0. So what is the reflectivity at the output side of the fiber you have to calculate. And you have to given that attenuation ratio of that 10 ratio 10. So the power at the input you have to split into two port, that C and D you have to given that port C is AR and D port. So ratio is given to 10 ratio 90 in that case. So R2 you have to just given that R2 equal to N1 minus N2 upon N1 plus N2 का whole square. So one that N2 is the air, and N1 you have to give to 1.5. So you can calculate R2 equal to 1.5 minus 1 upon 1.5 plus 1. So it approximately will become around 1 upon 25. So power at the output side, P naught you have to calculate through that Pi, that input power, into that ratio of that attenuation, that coupling ratio, that output side, that input side 10 into 100, and that multiply with that reflectivity at that output side. So through this you can calculate the output of the power. That any doubt? You have to given that this type of the question will become your quiz, that end exam will also come like that. So you have to solve through that formula only. That you just remember that formula, and you just put a value. That we have only the remaining two class. So if you have any doubt regarding that from that week 1 to week 12, you can put to ask to question form or that Google Classroom, or you can email to me. That I and Jonek will be help you in that every case. That but we need that more number of the participation. Now that only the 4 or 5 people will be remaining in that class. Even I personally email to everyone there today. I have remind everyone. Have you got my email, Namita?
Yes, sir.
Yes,
Yes,
sir.
sir.
You
Yes,
got
sir.
the
Yes, sir.
right.
So we are try our best to connect with you. So can we schedule the class on Sunday, or this time is okay for you? Hello.
So Sunday is more convenient. So I think so only 5 to 6 people are there
Sunday
who are
also.
attending the classes. So it's better if these people are giving consent on Sunday, then Sunday is very convenient I think for everyone.
Ha- have you any WhatsApp group of that people that 213 or not there? Any
No, sir. No, nobody is connected
anyone
here.
not connected that?
No, sir. No one is connected in this.
So Jonek, you want to add something, or we can close this session now?
I just wanted to show this slicer.
Okay, I will stop that, Jonek.
Just sharing a product page.
Sir, hey, password power?
Come again.
The solution is not approved except from 8 week onwards.
Up to 7 is uploaded. 8 and 9 are pending.
Yes, up to 7 uploaded.
Yeah.
Sir.
It will be. I already mailed that. In 1-2 days is there.
8 and 9.
I wanted to show this
Thank you.
splicer,
And
like fusion splicer. How does
lecture
it work?
video, lecture class,
Could you type? I
So,
cannot make out
Somel,
the
your voice
word.
is not audible. Somel, can you type your doubt in that chat box?
So basically, how a fusion splicer works is it will. What's the image I'm looking for? Anyway, so
it's fine. So transcripts from for 9 and 10
onwards,
classes, transcripts are not there, sir. Video transcripts are not available.
I am writing, but I don't think it will be available on time. I'm sorry about the last 3 weeks. With 10, 11, 12, it's being written, then ma'am has to verify, then uploading. I don't think it will be there on time. I'm sorry, ma'am.
Okay, sir.
But we will try, like maybe not all 3 weeks, but at least 2 if we can do. But we will try, but I cannot promise anything because everything takes time.
Lecture transcripts are there are 8 till 89 only, sir. That was up to
Yeah.
9, 9, 90 week, I think so.
Yeah. Anyway, so this splicing device, it will to use it, you will first strip off all of the protective layers, and you will keep only the cladding and core of the fiber, and the device will. So you will insert one fiber from this side, other from the other side. The device will align the two ends, and then apply this arc so that the two of them melt and fuse to become one continuous fiber. So after after splicing, this is giving some very nice, very low loss, no stress. So everything is automated, and the product is also very expensive, and the size is near the palm of your hand. That's all. I just wanted to show this. That's all.
So Jonek, should we schedule for Sunday?
Yeah, let's make an announcement and have it Sunday evening sometime. 5 o'clock, 6 o'clock, 7 o'clock, which is better.
7 to 8 is okay. That I think. 7 to 8 fine.
Yes, sir. Yes, sir. Yes, sir.
Namita.
Fine, sir.
Yes, sir.
It's a little bit early, sir, if it is possible to 4 to 5 or something like that. Jagannath, what about your opinion? Please tell me.
Some people about that
He
after
already
5
left.
they have.
Like, I don't want to ruin your Sunday plans. That's why initially we started with mornings. Just 1 hour of torture, and then
Even
you
some,
have.
Evening
sir,
fine, sir. Evening fine.
even some morning is also fine if I don't know, like on